Okay, so we are really moving into real algebra now. Okay? I can't stress enough how important it is that you learn this stuff well and learn what it is called. Most of my students do not learn what it is called. And because of that, they have a harder time. I'm telling you, if you want this to be simple and easy, learn what every form is called, because it tells you exactly what to do in the form. It tells you exactly what you've been given in the form, right? So if you know the title, you know what to do, right? So there are three useful ways to write equations, okay? And we're going to talk about them. The first one you already know. What is it called?
Point slope form.
Right. It is no. Sorry.
Slope intercept form.
Right. It is the
That's
slope
what I meant.
intercept form. Intercept form.
That's right.
All right, and that is, what's the equation? Y
equals mx.
Yes, x plus b.
y equals mx plus b. It's a very, very famous formula. That is a very famous. It's on the cover of my Algebra 1 textbook that I will eventually be giving you guys. Right? Probably not till next year, probably. But it's on the cover of that. Is it on
Are we
the,
ever going to even use this?
I don't know. Let's focus on that. Y equals mx plus b. Very important formula. Why would you call that the slope-intercept form? Aiden.
Because when you're graphing for y and x, there's always a slope, and they always intercept each other. With two
They always intercept what?
each other.
At a point.
Well, you're thinking of a systems of equations. I'm just saying, like, if you had one equation and you graphed it,
Oh,
why would that be called, this be called slope-intercept?
it intercepts one of the...
Yeah, and the intercept we're talking about here when we say this is the y-intercept, right? Not the x-intercept. The x-intercept would be where it crosses this line. We're talking about the y, where it crosses this line, right? Right? Okay, why would it be called, why would this be called that? Somebody else. He got it started. What is in this? What did they give you in this? Lucinda. The M stands for what?
Mount slope.
Mountain slope. Oh my gosh, look. Oh my gosh, that's important. That's important. You don't take that like casually. That is important. If you know that something's written in slope intercept, you immediately know somebody gave you in that equation a slope. And it is M, right? You don't have to do any figuring, any calculating, any thinking, because you know this equation has a slope, and it's the M always, right? It's the number in front of the X. Okay, but why would they say intercept?
Because it intercepts with the y.
Wait, no. Why is this called a slope intercept? Where's the intercept? They gave it to you. The B is your intercept, right? That's why you want to know the topic, the title, because then immediately you know, oh, I have a slope and I have a y-intercept. That's it. Slope, intercept, slope, intercept, slope, intercept. I plot my intercept. If that was y equals 2x plus 3, I would immediately go up on my y-axis and put a dot at 3. And then I would do my slope from there. My rise over run, my rise over run, my rise over run, right? Really, really easy. As long as you know that. Okay? Really important to know both. Okay. The second one. Second useful way. Now, by the way, there's like an infinite number of ways to write equations. They're just not always useful, right? These are three that mathematicians have devised or have found are really, really useful. And the next one is called point slope. That's the one we're going to go over today after I finish telling you these three, okay? Point slope form. And this formula is going to scare the living daylights out of you. So Noah, brace yourself, okay? It's really, okay? It's going to scare you. And It is so easy and so useful once you understand it. But it is scary to look at. This is it. Y minus y sub 1 is equal to m times x minus x sub 1.
Well, I'm done.
Right? I can see you guys trembling in your seats, right?
Alrighty then.
Don't worry. It's not as bad as it looks.
Yeah, it is.
Yes, it is.
It's like, and then you do
What is
All right, so wait a minute. Wait a minute. So why would they call this the point slope form? Because it's scary.
Because it's
What
like
do
a
you
roller
s-
coaster. It's going down. That's when your heart starts to beat really fast.
Okay,
and you freak
okay,
out.
okay. So what do you think they might have given you in this form?
A point and a slope.
A point and a slope. They did. What is the slope? M. Right, they gave you an M. You don't have to do any calculating. It's right there. Whatever's in front of the parentheses is your slope. Period. End of statement. Like, so easy. But they also gave you what? A point. Now, the thing is, the point you have to know how to find. The point is this. The point is x1, comma, y1. That's your point. And we're going to go over this. And I'm going to show you. It's a little confusing at first. But once you get it, it's like so easy, right? It's going to click. There's going to be a point in this process where suddenly, you're going to be confused and you're saying, "What is Gary talking about? This is ridiculous. What are these mathematicians all about?" And then all of a sudden, oh, I get it,
Yeah,
right?
that's a comma. Is that comma?
Well, no, there is a comma in here too, but I didn't want to write it.
What are you doing?
So, x1 and y1. Okay? Okay. So we're going to talk about this in just a second. We're going to decipher this equation, and you're going to suddenly get it, okay? It's almost as easy to graph something in point slope as it is in slope intercept. You can graph within 10 seconds anything in point slope. Very, very quick. Once you understand how to do it, okay? The big key, the M is really obvious. It's right there. The big key is finding out what is your point and how to figure that out. And I'm going to show you that in just a second. But I want to show you the 3 useful ways because it's really important to know all of them. And we are going to study all of them. We've already studied the first one. Today we're studying the second one, and someday we'll study the third one. I don't know when. Someday. The third one is called the standard form. The standard form. And this one has a formula like this. AX plus BY equals C.
Oh, okay.
AX plus BY equals C. So make sure that's all in your notes. Make sure you've written everything down. Okay. So notice it has an X and it has a Y. Now the A and the B and the C are all numbers. Like an example of this would be 2x plus 3y equals 6. That would be an example of something written in standard form. What do you notice that's different about the standard form from all the others? Yes?
It doesn't equal y equals a number.
Okay,
yeah.
okay. And what about the x and y? What do you notice that's unusual about that with the standard form? Gabe?
They're on the same side.
They're on the same side. Standard form has the x and y on the same side, right? So that's a good way to identify standard form. X and y are both on the same side of this equal sign, right? Okay, yes, Ava.
Also, the y is being multiplied.
And the y is being multiplied. Now, yeah, good point. That's right. The y is being multiplied. Sometimes you'll see an equation like this where it has 2y is equal to something, and you think, oh, it looks like slope-intercept, but you can't. You've got to divide everything by 2 first, right? We're going to talk about that eventually. We'll be doing more of those. But for now, that is, you're right, though. A lot of times with standard form, you have you have a number in front of the x. You're multiplying the x by a number, and you're multiplying the y by a number, right? So yeah. All right, so those are the three useful ways of writing equations. All three of them are very easy to graph. This one takes a little bit longer, but not a whole lot longer. You could probably do it in 15 seconds, right? But we're not going to talk about the standard form today. We're going to talk about the point-slope form. And I'm going to just erase number 3 now. And I'm going to leave the rest up there for a second, because that's what we're going to go over. So point-slope form. Okay, so I'm going to give an example. I'm going to write a problem. Or should I do it the other way around? Maybe I should give you a point and say, let's put it into the formula. Let's do that. So I'm going to rewrite the formula. Y minus y1. Now, what is this y sub 1 thing? Does anybody know? It's a way, it's actually, what is a point? A point is what comma what? X comma y, right? So it actually, a point actually has an x in it and a y in it, but the equation also has an x in it and a y in it. Do you know what I'm saying? So you have to have a way to differentiate between the x, the y that's like the y of this, and the y that's of the point. Does that make sense? You have to know the difference between the two because they're different numbers. And so you have one is y and one is y sub 1. Just because they're different, but they're also both y's, right? So you want to maintain that identity of a y, but you want to maintain their separateness, right? They're not the same thing. So you'll see what I mean in a minute. So equals m times x minus x1, right? Now, let's say I want the point to be, I'm going to give a point, and I'm going to give you a slope, and I'm going to ask, ask you guys to write an equation given the point and the slope. So let's say the point is, you're already here. Point is 2, 3, and the slope is 1/2. Right? Slope is 1/2. So make sure you write all this down. Okay? All right. So we are going to do this. Remember, the point is x1. Whoops. I totally messed that up. X sub 1, comma y sub 1. So my x sub 1 is 2. Does that make sense?
Yes.
And my y sub 1 is 3. I've got to plug those in. So wherever I see x sub 1 in this formula, I've got to put a 2. And wherever I see y sub 1, right there, I got to put a 3. And what is the formula? What is the variable used for slope? M. So wherever I see m, I've got to put 1/2. So all I do is I'm just plugging it in, right? It's really easy. So we got y minus, and then I have y sub 1, right? That's 3. Minus 3 equals, m is 1/2, parenthesis, because you always have parenthesis after your slope, right? And then, where am I? X minus x sub 1. That is this, the 2. And I put a 2 right here. All right. So that wasn't hard, was it?
No.
That was easy. All right. But I want you to look at something for a second. The point is positive 2, comma, positive 3. Am I right? You watching, Henry? You got to see this. This is really important. You're going to be so lost if you're not watching it now. Savvy, watch. Eyes up here. Everybody watch. Eyes up here. The point is a positive 2, comma, a positive 3. Look at the equation. It's a negative 2 and a negative 3. Why? Because the formula has the negative in it. Does that make sense? Look, the formula has a negative. So if the formula has a negative, I'm just plugging in. So my point is going to be the actual point is always the opposite of this, comma, the opposite of this. Does that make sense? So the opposite of negative 2 would be positive 2. The opposite of negative 3 would be positive 3. Okay? So do you see that? So it's always going to be, the point is always going to be, and it's weird because you have to go to the far right to get your x. You'd think that this would be your x, right? But this is your x. It's weird. Why? Weird. Whatever. Right? It's just weird. But your far right is your x now. So it's the opposite of that, comma, the opposite of this. That's how you always identify your point. All right. So that's pretty clear. Now let's try another one. I'm going to give you another. Okay, so let's say the point is -7, comma 12. And the slope was -2/3. Okay? You writing this down? Right? The point is that, and the slope is that. So go ahead and write it in your notes. Write the equation. See if you can do it. But notice the signs. Well, actually, maybe I should do this one together with you guys.
Yes.
Why? Because when it's just plain old y and plain old x, they stay as plain old y's and plain old x's, right? It's just the y1s that change, and the x1s and the m. So y, now it says minus, the formula says minus, and then my y is positive 12, so I'm going to put it 12. Okay? Equals, my slope is -2/3, parenthesis, and then I have an x, and then I have a minus in the formula. But look, my x here is an x1 is a -7. So that means I have to write minus a -7. What's minus minus 7? Plus 7, so that becomes a plus. And that makes sense because our point should be the opposite of this, which is -7, comma, the opposite of this, which is +7. Does that make sense?
Yes.
-7, I mean not +7. +12, right? -7, comma, +12. -7, comma, +12, right? Yes, question?
No.
Stretching, okay. Stretching?
2 hands.
2 hands, 2 questions, 2 stretches, okay. All right. So now we're going to make it harder on you guys, okay? I'm going to make it harder on you guys. So I'm going to write an equation, and I'm going to ask you to tell me what is the point. Okay? So y minus 2 is equal to 1/2 x plus 5. All right, Weston.
2 comma -5.
Think about it. Which one is the x? The x of 1 goes with this x.
Comma 2.
Yes, so it is going to be. The point is -5, comma 2, right? It's the opposite of this, which is now negative. Opposite of this is positive. There we go. All right, how about this one? Y plus 4 equals 2 times x plus 6. All right, Graham.
-6, -4.
-6, -4. Oh, very good. -6, comma, -4. All right. How about another one? Y minus 10 is equal to 4 times x plus 1. Okay. Violet.
1, -10.
Say it again. Look at it again. Look at it again.
-10,
Look at it again.
Yes.
It's the far right one first,
Yeah.
but it's the opposite of what you see there. You're saying exactly what you see there. It's not positive. What's the opposite of positive one?
Negative.
Right, so it's -1, comma, what?
Positive.
Yes, it's got to be the opposite. You got to make sure. You got to, slap yourself if you have to. Whatever you have to do, wake yourself up. It's got to be the opposite. And double check it before you start graphing. We're going to start talking about graphing in just a second. Graphing is really easy to do these. One more, and then we're going to graph. Okay. Y plus 1 equals 1 times x plus 1. All right, Noah. Look at this. Noah, look up here. Look here. Y plus 1 is equal to 1 times x plus 1. What is the point? It's going to be the opposite. Yeah, opposite of this. Yeah, -1, comma. Yes! Said with confidence. You did it.
Sure.
All right. -1, comma -1. Look at that. Perfect. Right? Fist of 5. Pretty easy, right? When I first wrote that, how many people were a little nervous? Yeah, right? Yeah, most people are, right? It looks like a nightmare. It's not a nightmare. It's your friend. There are some great, this is a great, easy way to solve problems. You'll see eventually. But now what we're going to do is graph. How would I graph these? You guys tell me. Let's talk this one. Let's look at this one. How would I graph this? Great.
That's where you start from. So that's where you
Ooh,
go
I know.
first, and then the slope. So for that one, it would be 1/2.
So you're saying I could take this point that I just identified
Yes.
and I could graph it? Okay,
Yes.
hang on 1 second. Where am I? Will I be able to do this? Sorry guys. Okay, we're moving. Okay, I think that'll work. Okay, whatever. We'll try. All right, so it's -5.
Down 5.
Kind of hard to
They're
see.
5/2.
Now.
All right, let's just do this in black.
The next.
Okay, so we have, the point was -5 up 2. So 1, 2, 3, 4, 5.
Up to.
Am I still on the graph? Up 2, put a dot. Okay, from that dot, from that point, like Graham said, I used my slope, right? What's my slope?
1/2 or
1/2. So that means from here, I put my pen on that dot, on that point. You guys all with me? All right, and I rise 1 and I run 2, and I put a dot. Rise 1, run 2, put a dot. Rise 1, run 2, put a dot. Look how fast that was. It was easy. Right? Easy.
Makes sense.
Does it make sense?
Yes.
Awesome.
Not
All right, now what about this one? Let's try this one. -6, -4. Did you
I
get,
didn't know.
you didn't follow this
Start
one?
negative No, I didn't. I don't get it. Like,
Okay. Do you get how to find the point?
yeah.
The opposite of this, comma, the opposite of this, right?
Okay. Yeah.
Right? So the opposite of 5 is
And then it just works
-5.
like
The opposite of -2 is
No, I know
positive.
that. It's the graphing.
So
part that
you know how to find this point? You go to 0, 0, and you go to the left 5.
Left 5.
1, 2, 3, 4, 5,
Up 2.
and up 2, right?
Yeah. Yeah. I get
Up 2,
that.
there's my point. And then from this point, I use my slope, rise over run.
Up 1.
Look at my slope. What is my slope?
But do you use?
This is
the
my
one
slope
that's
right
in
here.
there? Oh, okay.
So I'm
That's
rise
the part that I was focused on.
over run. Does that make sense? So I'm rising 1 and I'm running 2.
Easy.
Yeah? Does that make sense?
Like for those ones, would you just put a line and then one of these?
Yes. So great. So that was a great question. Mara noticed that this 2 is not written as a fraction, right? So you make it a fraction, right? You make it a fraction. Fractions are your friends. They're your friends. Trust me. You're going to like fractions. You better like fractions, right? They are your friends. All of these are fractions. All of them are fractions, right? Always make them a fraction. So let's do the next one. We'll see how fast it goes. It says -6. 1, 2, 3, 4, 5, 6. -4. 1, 2, 3, 4. Put a dot. And then what's the slope?
2 over 1.
So that means I'm rising 2 and running 1.
Running 1.
So I rise 2 and I run 1. Put a dot. Rise 2, run 1, 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 right? So I've got a nice another line, right? Maybe 10 seconds, right? Maybe 15 at the most, right? All right, next one. We got -110. Okay. Okay, Thorne, you help me. Or question,
I was
statement.
gonna say for the last 8 minutes, can we do whiteboards for these?
No.
We'll see. I don't know. Maybe. We'll see. So help me. Help me with this one, Thorne. So we're doing this one now. We're going to graph this one. So the point is what?
-1, 10, so you
Opposite?
go
Yeah.
up
Okay.
10,
Negative. What do I do?
up 10.
Well, wait. No. I go -1 first. You always crawl before you fly or whatever.
One, go.
Right? Didn't you guys crawl before you flew? Isn't that right?
Yeah.
Right? Whatever. Okay.
-1 to the left,
So what? Okay. Go 1 to the left.
and then 10 up.
And then 10 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a dot. Now what?
Rise 4, run 1.
So you're using the slope, right? He's rising 4 and running 1. So he's rising 4. 1, 2, 3, 4. Run 1. Oh dear. Okay, you got the idea, right?
Yeah.
So I'll just draw my line. Okay, so that's fast, right? It's easy. It's easy. So you now know 2 ways, 2 useful ways to write equations and to graph equations. So when something is written in slope-intercept form, y equals mx with speed, very famous formula. Immediately you know you were given a slope and you were given a y-intercept. Immediately, right? And then when you were given something in this form, you realize it's point slope. Immediately you know you were given a point and a slope, and you identify them in graph, right? Piece of cake. Fist of 5. How are you guys getting with this? Making sense? Awesome. Great. So that's it. That's my lecture. Okay.
Oh, thanks, Gary.